Hi students, welcome to the frequency shifting property session of Fourier Transform, right? So this is a very important property. Let us see this. So the property states that if x of t has a Fourier transform of x of omega, then Fourier transform of x of t into e power j omega naught t is given by x of omega minus omega naught. This is what frequency shifting property of Fourier transform. Let us see the proof. Right? So what we have to find the Fourier transform of x of t into e power j omega naught t. We know that Fourier transform equation is minus infinity to plus infinity. X of t is given by x of t e power j omega naught t. This is what our x of t. For that we have to find the Fourier transform. So e power minus j omega t dt. It's a Fourier transform equation. Right, instead of x of t we have x of t into e power j omega naught t. So simplify this. X of t e power minus j you take outside, omega minus omega naught t dt. Right, yes or no? So if we have a simply e power j omega t, we will say it is Fourier transform of x of omega. If we have our equation as x of t e power minus j omega t dt, we will say it is x of omega. Here instead of omega what we have is omega minus omega naught. So what we have to do here is it is given by x of omega minus omega naught. That is what Fourier transform of x of t e power j omega naught t. Fine. So you see that this is the equation proved. Fine. So simple proof. Clear. So Fourier transform of x. Similarly, we can prove that Fourier transform of x of t e power minus j omega naught t is given by x of omega plus omega naught. Right? So these two equations are very important. Here x of t is multiplied by some complex exponential with the frequency omega. So that's why it is called frequency shifting of your input signal. Right? So here you see multiplied with some frequency component. So what is happening here? The spectrum is shifted. Clear or not? So here it is, when you multiply your time domain signal by some complex exponential, the frequency domain, the spectrum is shifted. Yes or no? By the same amount, omega naught. Here I multiply by omega naught, so it is shifted by the same amount omega naught. Right? Since e power j, we have multiplied x of t with e power j omega naught t, but e power j omega naught t is complex function. We cannot generate, right? So what we have to do, I can multiply x of t with in real time, right? In real, we cannot multiply x of t, your signal, with e power j, because it's a complex that cannot be created. It can be multiplied with sinusoid. In real, x of t must be multiplied with sinusoids. That's very important. Okay, so x of t into e power j omega naught t we don't have normally in practice. What we have is x of t into cos omega naught t. We know that cos omega naught t is equal to e power j omega naught t plus e power minus j omega naught t divided by 2. It is like multiplying cos omega. If you multiply anything with the cos omega t, it will be equivalent to multiplying with the e power j omega t plus e power minus j omega t by 2. So we in real time we do this one only. So what will happen? Right? We know that x of t has Fourier transform of x of omega. X of t into e power j omega naught t has a Fourier transform of x of omega minus omega naught. So here x of t into 1 by 2 into e power j omega naught t plus e power minus j omega naught t. It will give Fourier transform of 1 by 2 x of t into e power minus j omega t we can write as x of omega minus omega naught plus x of e power minus x of t into e power minus j omega naught t x of omega plus omega naught, right? So this is one of the most important property. This is also known as modulation property. This is what modulation is. You will study modulation in detail in 4th semester. So just you understand what is modulation. This is what modulation, right? So simple logic, right? So for example, if you have a x of t, let us assume this is your x of t, for example, and it has a Fourier transform of x of omega minus omega 2 plus omega, right? What will happen if you multiply this signal with cos? Cos will be like this, right? This is what your cos. Fine. So this is our original signal, right? So what will happen? The spectrum will be shifted by omega naught. Fine. So x of omega minus omega naught means it will be shifted right hand side. This is x of omega, so it is x of omega minus omega naught. So this must be omega naught. Yes or no? Plus x of omega plus omega naught. So omega plus omega naught means it will come to left hand side. It is minus omega. This is x of omega plus omega naught. This we know, time shifting, right? So frequency shifting. Right now, another thing is if it is having amplitude of 2, what will happen? The amplitude reduced by half. So 2 divided by 2, 1. That is another thing we must remember, right? Otherwise, you may forget. So you see, this is what the difference between x of t. This is x of t into cos omega naught t. If x of t has a spectrum like this, x of t into cos omega naught t has a spectrum like this. That is frequency shifted. Here it is at 0, here it shifted to omega naught. That's what modulation means. We will study in detail in later subjects, right? I hope you understand this concept. If you have any doubt, please ask me in comment section. I will clarify. Thank you.